In this video, we're going to start by graphing horizontal and vertical lines and trying to look at their equations. In our last lesson, we learned how to graph diagonal lines using their equations. These lines had slopes that were either positive or negative. But in this lesson, we will learn how to graph vertical and horizontal lines. Before we get into those examples, though, let's look at the characteristics of vertical and horizontal lines. In our first example, a vertical line has been graphed. 4 points were plotted on the line. Write the coordinates of the 4 points. So we have point A, point B, point C, and point D. And we're going to write their coordinates. All right, well, point A, from the origin, we go 4 units to the right and then 8 units up. So A is at 4, comma 8. Point B, we go 4 units to the right and 5 units up, 4, comma 5. Point C, we just move 4 units to the right and stay there, 4, comma 0. And then point D, 4 units to the right and 3 units down, 4 comma -3. What is common among the 4 points? Well, if you look at all 4 points, notice that they all have the same x coordinate. All right. The x coordinate of each point is 4. Okay, and so if I wanted to create an equation for this vertical line, I could simply say that x equals 4. All right, any point that's on this line is going to have an x coordinate of 4. So this vertical line here has the equation of x equals 4. In our next example, a horizontal line has been graphed this time, and again, 4 points were plotted on the line, A, B, C, and D. Let's write their coordinates. All right, point A, point B, point C, and point D. All right. To get to point A from the origin, we had to go 4 units left and 7 units up, -4, comma 7. For point B from the origin, we simply moved straight up 7 units, so 0, comma 7. For point C, we moved 2 units right and up 7, 2 comma 7. And for point D, we went 6 units right and up 7, 6 comma 7. What is common among the 4 points this time? Well, if you look at all four, they have the same y coordinate. The y coordinate, the y coordinate of each point is 7. All right, the y coordinate of each point is 7 here. So what equation could we use to represent this horizontal line? Well, we could simply say that y equals 7. Any point that is on that line is going to have a y coordinate of 7, so the equation of the line is y equals 7. Our previous two examples have shown us what the equations of vertical and horizontal lines will look like. All right, if I have a vertical line, then my equation is going to be x equals some constant a. All right, the line x equals a is a vertical line at a. Okay, so the value of every x coordinate on that line is going to be some constant, and it's going to be a vertical line like this. Remember that the slope of any vertical line is undefined because there is no horizontal change. Remember that to find slope, m equals delta y over delta x. And since there is no horizontal change, your denominator would be 0, which automatically means that the slope is undefined. If you have a horizontal line, all right, then the equation is going to look like y equals some constant b. Y equals b is the equation of a horizontal line. Every horizontal line is going to have a y coordinate of whatever the value of b is, okay? And remember that the slope of any horizontal line is 0. Okay, for slope again, m equals delta y over delta x. And because there is no vertical change, I'm going to have 0 over whatever the change in x is, which is always going to equal 0. So the slope of any horizontal line is 0. So again, x equals a constant is a vertical line, y equals a constant is a horizontal line. In our next example, we're going to graph the equation y equals 8 on this graph right here. Okay, we're going to label the graph with its equation, and it's important to realize here that it says y equals 8. When y equals a constant, remember, then that means it's going to be a horizontal line. Y equals some constant is a horizontal line. And for this example, if y equals -8, that means that any point on that line is going to have a y coordinate of -8. Okay, so it doesn't matter which direction we move left or right to start out. The y value, though, is going to be -8. So any y value that is -8, we can plot those points. So -8, -8, -4, -8, 0, -8, 5, -8, 9, -8. All of those points there have the same y coordinate of -8. And so we can use our ruler and connect all of these points now. All right, and again, any point that's on this line is going to have the y coordinate of -8. So there's our line, and I'll put arrows on both ends. And I'm going to label this line y equals -8. That's the equation of the line. And remember that the slope here is 0 because there is no vertical change. So m equals 0. And b, the y-intercept, well, it crosses the y-intercept here at 0, comma, -8. So the value of b would be -8. So another way of thinking about this equation, we could write y equals 0x minus 8. Okay, there is no vertical change, so the slope here is going to be 0. So 0 times x, well, that's just 0. And 0 minus 8 is -8, which is how we end up with that equation again, y equals -8. Our next example wants us to graph the equation x equals -3 on this graph. And again, we're going to label the graph with its equation. And we said before that if the equation says x equals a constant, we're going to be graphing a vertical line. Every x coordinate is going to be -3. So no matter which point I'm working with, if I start at the origin, I have to first move 3 units to the left and then move vertically up or down. So I can plot the point 8 comma -3, that would be on the line, or 4 negative, or -3 4, I should say, that was -3 8. -3 4 is on the line, -3 0 is on the line, -3 -5 is on the line, -3 -10 is on the line. Lots of different points on that line. Every x equals -3. So if we connect these points now with our ruler, that's going to give me this vertical line right here. Put arrows on each end. And the equation of that line, x equals -3. That's the equation of that line. The slope here is undefined, okay? Undefined because there is no horizontal change. There is no run in this example. So the slope is undefined. And the y-intercept doesn't exist, so I'm just going to write n/a. This vertical line is parallel to the y-axis, so it's never going to cross the y-axis, so there isn't a y-intercept of b. Our next example says to graph the equation y equals 3 on our graph and label it with its equation. Y equals a constant is a horizontal line. Every y coordinate is going to be 3. So it doesn't matter which direction or how many units you move left or right, you're going to have to move up 3 units from there to be on y equals 3. So I could go to -6, 3. I could go to -10, 3. I could go to 0, 3. I could go to 4, 3. I could go to 7, 3. I could go to 10, 3. All of those points are going to be on our line y equals 3. So let's go ahead and connect those using our ruler here. There we are. There is our line, arrow, and arrow. And we'll label this one as y equals 3. That's the equation of the line. Since the line is horizontal, the slope is 0. And the y-intercept is right here at 0, comma 3. So the value of b is 3. Our next example wants us to graph x equals 6 on the same graph that we just did our previous example. Label the graph with its equation. X equals a constant is a vertical line where every x coordinate equals 6. So I'm going to have to move 6 units to the right, and then it doesn't matter how many units I move vertically. So I could do 6, 0. I could do 6, 7 right here. I could do 6, 8. I could do 6, -4. I could do 6, -10. All of those are points that are going to be on this line. Use your ruler and connect them. And it'll look something like this. It's a vertical line. And for every point on that line, it has an x coordinate of 6. So x equals 6 is the equation of that line. And remember that the slope of a vertical line is undefined. And the y-intercept here is not going to exist, n/a, it's not applicable because this vertical line x equals 6 is parallel to the y-axis, so they are never going to intersect. In the next part of our lesson, we're going to be writing equations of lines from tables. In previous lessons, we've been writing equations of lines when we had a graph of the line, okay, but here we're going to have a table of values. Now recall that the equation of a line written in slope-intercept form is y equals mx plus b. M represents the slope of the line, and b represents the y-coordinate of the y-intercept. We've used graphs and tables to calculate slope, and now we'll see how we can write the equation of the line from the table of values. So here in our first example, we've got this table of values. We're going to use that to first calculate the slope, which is the rate of change for our line. So what we need to do for each of these x values and each of these y values is determine how much it's changing from row to row. So first with the x's, to go from -2 to 0, we added 2. To go from 0 to 2, we added 2. To go from 2 to 4, we added 2. With the y's, to go from 8 to 0, we subtracted 8. To go from 0 to -8, we subtracted 8. To go from -8 to -16, we subtracted 8. Remember that slope is your change in y over your change in x, delta y over delta x. And we just saw here that in our y column, to go from row to row, we had to go down by 8 every time. So -8 is the change in y. And when we went down by 8 every time with the y values, we went up by 2 every time with the x values. So m equals -8 over 2, which we could simplify down to m equals -4 over 1, which means that our slope here, m, is -4. Our slope is -4 in this example. Now, for the y-intercept, remember that the y-intercept always has an x coordinate of 0. So to find the value of b, we need to go to where x is equal to 0 in our table. And in our table, we see here when x is 0, y is also 0. All right, so in this example, b equals 0. Therefore, the equation of the line going through these points, we can set up the following way. Remember, it's y equals mx plus b. We just found out that our slope is -4, so it's -4x, and our value of b is 0. So we have -4x plus 0, but if you add 0, well, that's just -4x. So the equation of this line from the table would be y equals -4x. In our next example, we're going to use the table to calculate the slope and then find the y-intercept of our line. So starting with the slope, we again have to figure out how much are the x's changing from row to row and how much are the y's changing from row to row so that we can set up our slope formula or slope ratio. For the x's, to go from -2 to 0, we added 2. 0 to 2 is add 2. 2 to 4, we add 2. 4 to 6, we add 2. With our y's, to go from -4 to 2, we added 6. 2 to 8, we added 6. 8 to 14, we added 6. 14 to 20, we added 6. And so for this example, m equals delta y over delta x. Our change in y every time we added 6. Our change in x every time we added 2. So our slope is 6 halves, which is 3 over 1, or 3. That's our slope, m equals 3. For b, remember that your y-intercept is always found at a point of 0, comma something. Your x-coordinate is 0. So in your table, find x is 0, and that's going to give you the value of b. All right, b in this case is 2. So our equation, when we write it, is y equals mx plus b. Our slope m is 3. Our y-intercept value is 2. So the equation of this table, y equals 3x plus 2. Our next example again gives us a table of values to use to figure out the slope and y-intercept so that we can write the equation of the line that would go through these points. Okay, so once again, we're going to figure out the slope first. So notice it's a horizontal table this time, no difference than being a vertical table. You just have to find the change in your x's from column to column, and then your changes in y's from column to column here. So let's start with the x's. From 2 to 4, we add 2. 4 to 6, we add 2. 6 to 8, we add 2. For the y's, from 5 to 8, we add 3. From 8 to 11, we add 3. And from 11 to 14, we add 3. So for the slope, delta y over delta x, every time we changed in y's, we went up by 3. Every time we changed the x's, we went up by 2. And that does not simplify, so that is our slope, m equals 3 halves. For b, remember again, the y-intercept can be found when your x-coordinate is 0. So we have to find in our table where x equals 0. Well, unfortunately here, x equals 0 isn't here. All right, that's what's different about this table. I don't have x equals 0, but I can use this pattern to figure out what it would be. All right, we went from 2 to 4, 4 to 6, 6 to 8. Well, let's go the other direction. 8 to 6, go down 2. 6 to 4, we go down 2. 4 to 2, we go down 2. 2 to 0, we would have to go down 2. So we're doing the opposite of what we did originally. We're going down 2 this time, which means I'm going to have to do the opposite this time. 14 to 11, down 3. 11 to 8, down 3. 8 to 5, down 3. So I'm going to go down 3 again. When x is 0, 5 minus 3 is 2. 0, comma 2. B equals 2 is going to be my y-intercept. Okay, so again, I just had to go down 3, moving the other direction. 5 minus 3 is 2. When x is 0, y is 2. So that's our b value. So for the equation this time, y equals mx, which is going to be 3 halves x, plus b, which is 2. We have another table of values in this example that we can use to figure out the equation of the line. All right, so let's use our values to first calculate our slope, then we'll determine our y-intercept, and we'll write our equation in slope-intercept form. So let's start with the x's. To go from negative 3 to 2, we add 1. To go from negative 2 to negative 1, we add 1. Well, if we continue this pattern, if we go from negative 1 and add 1, we're going to have 0. And then to go from 0 to 1, we add 1. For the y's, from 7 to 5, we subtracted 2. From 5 to 3, we subtracted 2. Keeping the pattern going, 3 minus 2 is 1. And then to go from 1 to negative 1, we subtracted 2. So for slope, m equals delta y over delta x. And in this case, the change in y's every time we went down by 2, so negative 2. Our x went up by 1 every time. All right, so we have negative 2 over 1, which means that the slope is negative 2. For our y-intercept b, that's at the point when x equals 0. Here is where x is 0, y is 1, so the b value is 1. And so the slope of the line that goes through these points from the table, y equals negative 2x plus 1. Let's use this table of values to figure out our slope and y-intercept so that we can write the equation of the line that represents this table in slope-intercept form. Okay, so let's take a look at what we've got here. We'll find our changes in our x's. From -3 to -1, I'm going to add 2. From -1 to 1, I'm going to add 2. From 1 to 3, I'm going to add 2. All right, for my y's, to go from 10 to 4, I subtracted 6. To go from 4 to -2, I subtracted 6. And from -2 to 8, I subtracted 6. So for our slope, m delta y over delta x. All right, our change in y, every time we went down a row here, we subtracted 6. M equals -6 over our x is increased by 2. So that's going to give us -6 over 2, which is -3 over 1, meaning the slope is -3. All right, for the y-intercept here, again, that's when x equals 0. Well, in my table, again, I don't have x equals 0. And my pattern, where I added 2 every time, I actually skipped over. All right, so from -1 to 1, I added 2. Well, if I wanted to get 0, to go from -1 to 0, I would have to add 1. I did half of this change. Well, if I do half of this change in the x's, I'm going to do half of this change in the y's, which means I'm going to subtract 3. 4 minus 3 is 1. So 0 comma 1 is where the y-intercept is going to be. So b is equal to 1. So the slope here is -3. The y-intercept 0, 1, b equals 1. The equation of the line y equals -3x plus 1 is represented by this table. In our next table, we're going to find the slope, the y-intercept, and write the equation of the line that would be represented by this table of values in slope-intercept form. All right, so let's look at our changes here. To go from -3 to -1, we would have to add 2. To go from 1 to 5, we would have to add 4. In the y's, to go from 1 to 7, we would have to add 6. And in the y's from 13 to 25, we would have to add 12. All right, and so let's look at our rates of change here. All right, so for this example, again, it's delta y over delta x. The change in y here was 6. The change in x was 2. That's going to simplify to 3 over 1, or 3. All right, in this one, the change in y was 12. The change in x was 4. 12 over 4 also simplifies down to 3 over 1, or 3. So I know my slope here, m, is going to equal 3. Now I need my y-intercept. Okay, so here I went from -3 to -1. From -1 to 1, I would have to add 2, but I want to go to 0. From -1 to 0, I have to add 1, which is half of this change right here. Well, from 7 to 13, I add 6. So since I did half the change here, I'm going to do half that change here. Half of 6, I'm going to add 3. 7 plus 3 is 10. So 0 comma 10 is going to be the location of the y-intercept, which means that b is 10. And so for the equation of this line, y is going to equal 3x plus 10. The slope was 3. The y-intercept b value was 10. Y equals 3x plus 10. Here's a table from Delta Math. Very similarly, we're going to use this table to calculate the slope and the y-intercept of our line so that we can write our equation for this table in slope-intercept form. So let's see what's happening in our table. To go from -1 to 2 in the x column, we had to add 3. To go from 2 to 5 in our x column, we had to add 3. And to go from 5 to 8 in our x column, we added 3. So we're increasing by 3 every time in our x column. With our y column, to go from 5 to 2, we had to subtract 3. To go from 2 to -1, we had to subtract 3. And to go from -1 to -4, we had to subtract 3. So for our slope, delta y over delta x. All right, well, our change in y every time we went down by 3, so -3. Our change in x every time, though, we increased by 3, positive 3. M equals negative 3 over 3, which is the same as negative 1 over 1, or negative 1. Our slope here, m, equals negative 1. Okay, well, we have to try to figure out what our y-intercept is going to be. Okay, so we're going to have to use our table of values to figure out what that's going to be. All right, so if I had my table here, all right, I'm just going to redraw here. I know at x equals negative 1 that y was equal to 5. I want when x equals 0. Well, my slope here is negative 1, which means that I'm going to go down 1, right 1, down 1, right 1. Well, my change in x here, all right, I'm going to go up by 1. All right, well, I've got to try to figure out what that y value is going to be. Well, I went up by 1, so I'm going to have to go down by 1 in my y column here, all right? Whoops, I'm going to have to go down by 1, I should say. I put that in the wrong spot. My change is going to be going down by 1, which means that my y value here is going to have to be a 4, okay? By adding 1 in the x column, I'm moving right 1, and then I'm going down by 1 unit vertically. So down 1, right 1, down 1, right 1. This is going right 1 in the x column. This is going down 1 in the y column. So 0, comma 4 represents the location of the y-intercept b, which is 4. So our equation here is y equals negative 1x plus 4, which you could also simply write as y equals negative x plus 4. Okay, so again, we had to figure out what was that our y-intercept going to be. So we had to find when x was equal to 0. Since the slope was negative 1 over 1, I go down 1, right 1. Increasing 1 in the x is moving right 1. Decreasing 1 in the y is going down 1. So 0, comma 4 is where the y-intercept is going to be located.